Hey, you 10. I hope you're all well. Nice to see you all. Got 4 people waiting. Hey, you 10. Sorry, guys. Just going to pause that one. Nah. Right. Okay, guys. By the way, I did have somebody comment on the YouTube video or send me an email just asking about the quality of the video. If you go to the little settings in the bottom right-hand corner, if you go to the settings at the bottom right-hand corner, you can turn it up to HD 720p, and that'll make it a lot easier for you to be able to see me. You'll just get a better quality video. So if you need to do that, please do. Guys, say hello in the chat so I can do the register. That would be grand. Guys, today we're going to be looking at moles. I am very aware that I wouldn't say, hey Zihan, hey Ryan, hey Adri, nice to see you. I'm very aware that I would like to spend more time on this and go through equations with you guys. What I'm actually going to do is I'm going to link you guys. I'm going to link you guys to my other YouTube videos. I'm going to post them on the classroom for you guys to have a watch of the YouTube videos on equations. I'm very aware that we are behind, and I'd like to just make a little bit of ground on moles. I know that you should have already done equations with Miss All Day, but I'm just, as I said, you've already done them, but it would just be great for you guys to be able to watch additional videos on that, and just to be able to give you a bit more support. If you want the homeworks as well, I'm more than happy to post them on the classroom as well for you to have a go at. Right, look at that. People appearance is great. I've got Fatima. I'm just gonna, Fatima. I haven't got Chiman yet. I can't find the YouTube. I love that Ethan said that when he's on my YouTube. It's brilliant. I've got Kate. I've got Amber. Yep, got Amber. Got Zihan. Natanya. Nope, not got Natanya yet. Got Adri. Got Ethan. Ethan, can you explain on the YouTube chat what you mean? But I can't find just now. What? So you've now since found it? Do I have Bo Yang? Haven't got Bo Yang yet. Got Ryan. Got Oleg. Haven't got Mary yet. I can't find this live. Ethan, you're on my live stream. I'm not entirely sure what you're saying. So very confusing. Oh, it's brilliant. So I'm missing 4 people. I'm missing Chiman, I'm missing Tanya, I'm missing Bo Yang, and I'm missing Mary. I'll just give them a minute just to see whether or not they turn up. I nearly wanted to go to the Hangouts and ask for the video. Okay, so you haven't, obviously, you're on the live video now. I mean, I can't find... Ethan, it makes no sense. I'm so confused. But you have found it now, yes? You're on the chat. I found it now. Oh, Ethan, you've just proper made me chuckle. Yeah, brilliant. Right. Yeah, so still waiting on a couple, still waiting on Chiman, still waiting on Natanya, Bo Yang, and Mary. I'll check the Google Hangout just to make sure that nobody's messaged there, wondering where it is. We're still in good time. So 8:33, still doing okay. Let's see how long see whether or not they turn up. Interesting that if you've said, Ethan, that you struggled to find it, maybe they're also struggling. So I don't know whether or not you guys. Oh, there's Chiman, brilliant. It's in on the register, fantastic. Hi, Mary. So good to see you. There you go. Just missing Bo Yang. There's Natanya. And just Bo Yang to go now, folks. I'm sure he'll be in it momentarily. And then we can crack on. Guys, so how's everything going? Have you guys been enjoying your online learning? I always like to ask these kind of questions. Come on, Bo Yang, where are you? Good. No. Ethan, don't say that. We've got to try and make the best of a bad situation. Just joking. Oh, so funny. Right, so I think what I'll do is, if anybody's got Bo Yang's number, they can send him a message. I'm sure he will turn up eventually. Since there's only one person missing, I think I'll crack on with the lesson. What I'll do is I'll keep the register open just in case he decides to turn up. Okay. Okie dokie, guys. Right, let's crack on. Oh, actually, yeah, okay. Right. Okay, folks. So, moles. So, you guys have already covered this within this all day, but it's nice for me to just spend a bit more time looking at it. I'll share my screen. Otherwise, you're going to be looking at my forehead. There we go. Share. And then I'll click on that one. Still need to get myself a nice, decent webcam so I can you guys can see what I'm doing and I can do all my hand gestures. Okay, so I'll hide that and go straight over to here. So the first thing that we're going to go do, folks. Oh, I'm just suddenly realizing there might still be a chance. Okay, that's all sorted. Right. So the first thing I'm going to do is go through your homework. So I gave you a percentage composition homework. Only 4 questions. It was nice and short. I hope that you guys have managed to get it done. Guys, I really do stress the benefits of doing these short homeworks that I set you. They really, really do help solidify what we're doing in our lessons and in our discussions, and it will genuinely make you a much better chemist. So it's worthwhile taking a bit of time and doing these. If you ever want more questions, just send me a message on Hangouts. I've got more questions than you would ever be able to answer. And of course, if you ever need any or ever want to do any additional ones, please do ask. They do have such great benefits, especially on this topic. And there will be some of you who will want to take A-level chemistry. Just to let you know that I'm actually a dual scientist myself. And so it really doesn't impact as long as you spend the time doing the exercises and ask for those extension bits. You guys will be able to do A-level chemistry just as well as any triple award chemist. You do miss a few calculations out, but as I said, definitely worthwhile spending the time doing the homeworks and asking for any additional questions if you need them. Okay, so question number 1 started off with it's nice for us to do the name. So guys, on the chat, please. Impress me year 10. Can somebody name that, please? Can someone name that properly on the chat? Let's see how many people are going to remember what you have to do with those particular kinds of compounds. And could you also tell me what type of bonding is taking place in it as well? So these are just extra questions. So I just want the name of this guy and I want the type of bonding. It's always good to be able to reinforce, because everyone knows if you don't use it, you lose it. Copper bromide. So that's really okay. So Mary, well done, guys. So this one's actually a clever one, and it's always a trap at GCSE. It's not covalent, Zihan. It's definitely not that. Metal, non-metal. Natanya, well done on ionic. That's correct. Yeah, remember, if you've got a metal, and we know that copper's a pink metal, yeah, this is a metal, non-metal. I'm just going to swing over to this side. So CuBr2. Now, guys, the reason why this one is a trap, well done, Oleg, that's great. The reason why this one is a trap is because copper is a transition metal. This is a transition metal. So if you see a transition metal, then you have to remember that Roman numerals are needed. So I wonder if now that I've given you guys that hint, would you guys be able to now edit the name? So far, nobody has got it correct. So can somebody now post on that whether or not the correct name? It is definitely ionic. It is ionic because, of course, it's a metal bonded to a non-metal. It's always, as I said, we're just reinforcing bonding, because bonding is Ethan's now said copper 1 bromide, which is definitely not correct, but Natanya's given me the correct answer. Well done. So the name of this is actually copper 2 bromide. And the 2, just to remind you that the 2 is telling you the charge on the copper. Well done, Fatima. Oh yeah, it's 2. It's telling you that the copper is in a +2 oxidation state. The word oxidation state is the posh words for charge. Yeah, that's all that actually means. So it's telling you the charge on the copper. Yeah, so we've got copper 2+, and then we've got Br1-. Bromine's in group 7, it's always -1. So this is copper 2 bromide, and it's definitely ionic. Right, so let's now run its percentage composition. So percentage composition, I'll actually be good today. Percentage composition is wanted MR, and I'll put MR/AR because it can be atoms, it can be molecules, yeah, over total MR. This is actually not MR, this is actually RFM because it's ionic, but in this case, they wouldn't make any difference. And you can't forget the times 100. So let's now do it for copper. So we have got in this, we have got 1 copper. So copper is found on the periodic, this is where I shrink my pen. Copper is found on the GCSE periodic table, and it's always important that I flag up copper. Copper is one to know about. The reason why is because copper is a funny one like chlorine. There's 2 on the GCSE table with a 0.5. So this is 63.5. So copper 63.5 times 1, because there's 1 copper in this compound, all over copper 63.5 plus bromine 80, but there's 2 in it, so times by 2. Now, by the way, in that there, I'm going to then do times 100, just to let you know that I would lose the mark at GCSE for the working out. The reason being is you have to actually give the final number. It's a very common mistake for students to make, even at A-level, by the way. I'm just going to quickly add that up. 63, turn my calculator on, my help. 63.5 plus 80 times by 2. So I've got 223.5. So I'm going to go, therefore, 63.5 divided by 223.5 times 100. This is going to be the percentage of copper. 63.5 divided by answer times 100. And I get an answer for copper of 28.4%. Now, at this point, students often ask me how many significant figures do I do. At GCSE and A-level, the rule is always 3 significant figures. Yeah, and of course, this is actually 28.41163311. So I'm going to round that to 28.4. Right, so there's 28.4. Let's now look at the other one. Yeah, so I'm just going to quickly divide. I'm just going to give myself a bit more space. So I'm just actually going to take away the working of that one just to give me a bit more space. I don't really want to remove it. Yeah, I'm just going to move that over to there. I'll move this guy over to here. Okay, so I'm just going to draw a line to make it easier for me to separate the 2. There we go. So we've now got the percentage of bromine. Yeah, so the percentage of bromine is going to be wanted, which is Br80, but I have 2 of them over the same total that I had before, 223.5 times 100. By the way, don't forget, you've got to write down that times 100. Very easy to do that. So 80 times by 2 gives, of course, 160, divided by 223.5 times 100, and I get 71.6%. And what you'll notice is that, of course, because of this particular homework, what you notice is that there's a nice little confirmation here that these 2 add up. If I do 28.4 plus 71.6, I get exactly 100%, which tells me that I've got it correct. So you can tick that and, whoa, okay, that's a bit thick. You can tick, let's go for that one, tick that one and tick that one, 2 marks if you've got them. That'd be great. Right, next. Okay, guys, so again, another compound, super important in chemistry. Can someone do me a favor? Can you name it? Can you name this, please? Can you also tell me the bonding? Just on the chat, guys, type it in. That'd be great. Can you also do me a favor? Can you also tell me whether or not this is an acid or an alkali? Which one is it? Acid or alkali? Well done. Fatima's on the ball today. Oh, look at this. Fatima comes in first. Natalia's in second. Kate's in third. Amber's in fourth. Adri's in fifth. Natanya, check your bonding type again. Yeah, so the bonding type, Natanya, is not correct. Remember, by the way, I love that. Fatima, not correct there. It is not an acid. Yeah, and it's not covalent. It's ionic. So just to quickly swing over to here again. Thanks, by the way, you see why it's just important to reinforce these things, folks. Oleg, not an acid. So sodium hydroxide this is a very, very, very important chemical in chemistry because it is the most used alkali of all of them. So the first thing, the name, of course, everyone got correct. No Roman numeral needed here. This is sodium hydroxide. Well done, guys, for getting the hydroxide. The type of bonding is ionic. The reason why is because I have a metal. Yeah, sodium is a shiny silver metal. You guys have all seen it go into water, I've no doubt. And OH is a non-metal. So it's ionic. And anything that ends, this is where you learn. I do realize, by the way, that I'm very much, I shouldn't highlight it in blue. Can anyone tell me if I put this into universal indicator, what color am I going to be coloring this, please? Yeah, we know that the word hydroxide tells us the properties that this is going to be an alkali or otherwise known as a base. Now, just to tell you that the word base is actually the better word. Alkali is a base that is soluble. Yeah, but whereas, it's actually well done, Zihan. Spot on with the color. Well done. It's going to turn purple with the universal indicator. Great job. It's correct, Zihan. Spot on. But sodium hydroxide is an alkali because it's soluble. You could also call it a base as well. All alkalis are bases, but not all bases are alkalis. Just to tell you a little bit about that, we often, when we teach in year 7, we teach acids and alkalis. I actually don't teach that. What I teach, I think the reason why we do that is because of the 2 A's and how it rolls off the tongue nicer. I actually teach at year 7 acids and bases. Yeah, these are the 2 families. Yeah, 2 families in chemistry. We've got acids and we've got bases. Yeah, and in the base family is another family called alkalis. So all alkalis are bases, but not all bases are alkali. And the reason why alkalis are different is because they are soluble in water. It's always nice that. Students often then ask me, can you give me an example of a base that doesn't class as an alkali? And I always do that. And the one I always choose, of course, is calcium carbonate. This is limestone. Yeah. Limestone. This is again. You learn in chemistry. Oh, my pen's just done something funny. That's weird. Oh no. It's done this before, guys. What I'm going to do is I'm just going to quickly close this down. Just going to close that down and I'll bring it back open. See if that cures it. Every now and again, my tablet decides, look, it's doing something funny again. It's probably because it needs to be restarted. If I just, oh dear. That's always not good that when it does this. Not entirely sure how to rectify the problem as well. I had issues with this last time and I had to do a full laptop restart. Maybe if I change maybe if I change my pen. Look at that. It seems to just be skipping it. Very odd. It's done this before. I'm not entirely sure how to fix this, folks. Oh no. I'll try replacing the battery in my pen. See whether or not that makes it disappear. I still want to get rid of all these stupid little marks that I've now left. This is a problem. Sorry about this, folks. Don't really know how to fix it. I've got a really bad feeling that it's going to continue to do this. Oh, it seems to have repaired itself. So this one here is limestone, a very important chemical in chemistry. It shows up so often. Limestone is a white solid. It's actually used for making cement and concrete. That's why it's so important. But it's not soluble in water. If it was soluble, then the houses would dissolve when it rained. Okay, so let's now do percentage composition. Yeah, so we're doing the percentage of sodium first. So I'm going to try and divide up my page into 3. I think that's reasonable. So let's do sodium first. I'm going to shrink my pen, zoom in. So we've got I've got sodium, which is, so percentage comp is what I want, which is sodium 23 on the periodic table, times by 1 all over sodium 23 plus oxygen 16 plus hydrogen at 1, all of it times 100, and I get my percentage. Now remember, I'm going to lose 1 mark because you can't leave it like that. Yeah, so I'm assuming it's 40, 23, turn my calculator on, 23 plus 16 plus 1. I never, by the way, students often laugh at me, my A-level students especially laugh at me because they're like, can't believe you're not doing this in your head. I actually deliberately don't do it on my head. Oh, I love that Zihan's giving me the answer. So 23 over 40 times 100, and I get 57.5. Outstanding. Well done, Zihan. Great job. 57.5%. Right, next, now I'm going to work out the percentage of oxygen. So oxygen's percentage composition is going to equal, right, there's 1 oxygen. Oxygen is 16 times 1. And then I'm going to do over 40, which I already calculated, times 100. If I forget that, I'll lose a mark. So 16 over 40 times 100 gives me exactly 40%. Now, I've got to be really careful because I have to give 3 sig figs, so that 0 must make an appearance. And my calculator, of course, the calculator's the trap there. See, Zihan, it's very easy to make that 0 vanish. Do watch out for that. Edexcel love that trick. Yeah, let's now do hydrogen. We could actually work out the difference that I'm taking away from 100, but hydrogen is 1, yeah, over 40, and there's only 1 of it in it, times 1, times 100 gives me, so 1 over 40 times 100 gives me 2.5, and it will be 3 sig fig again, 2.50%. And what you'll notice is all of this adds up to 100% of sodium hydroxide, which is nice. All good. Next. Guys, this is one of the traps of Edexcel. So do please watch out for this one. So number 1, can somebody please on the chat name this? Impress me. That's hard. By the way, that naming question there is now, this is actually a level 7/8. Yeah, this is a 7/8. Do our marks get deducted for 3 sig fig? Not in this case, Ethan. The reason why is the question didn't state. The question hasn't stated 3 sig fig, so I'm not going to deduct it for this time. I'm just letting you know that all calculations, students often say to me, how many significant figures do I do? And there is a rule in chemistry, 3 sig fig unless stated otherwise. Adri, no. Great effort though. Fatima, no, not quite. Think about it, guys. Have another go. The people who are watching the chat and waiting for their answers to come in, those 2 have both got it wrong so far. Let's see who's going to get it first. Next thing, by the way, this is a trap. This one here, bonding, this is now a level 8/9. This is a love 8/9. Yeah, so watch out for that. Still no one on the chat who's giving me the correct answer. So 2 questions here. Ammonium sulfide. Well done. Good job, Zihan. Good job, Kate. Well done getting it correct. First one. Netanya, well done. Good job. That is correct. This is ammonium. Ammonium, because of course the ammonium, I'm going to color code this. Never do that. Ammonium is NH4 plus. And then, of course, well done on the sulfide. By the way, it is actually spelt with an F, not a PH. They wouldn't penalize you. So is sulfate. It's actually spelled with an F. The PH is an ancient misspelling. For anybody who watches my other webinars, there is a fate that actually is a PH, and that's phosphate because of phosphorus. The original spelling of sulfur was this. That's the correct spelling for sulfur. And the English people out there, the ancient English misspelling, then spelt it with a PH like that, which is not correct. That is actually wrong. Yeah, which means it becomes a sulfide. Yeah, sulfide. And by the way, that's just S2 minus, and then it becomes sulfate when it's SO4 2 minus. By the way, that's often a way of remembering it that I often mention, that the sulfide is a 2 minus because it's in the same group as oxygen. So the sulfate is the same. It's a really nice connection that. I very rarely remember to teach that, actually, just so you know. Whereas phosphorus is actually spelt like that. That is correct. So that becomes phosphide. Yeah, that becomes phosphide and then becomes phosphate. You don't need to actually know phosphate at GCSE, but you do need to know it for A level. So anyone who's thinking it's worthwhile knowing it. The phosphide, again, really nice thing to mention here. Yeah, if you find phosphorus on the table, phosphorus is in the same group as nitrogen. Yeah, which means, now this is a nice thing for me to remind you guys. Yeah, so one of the things just to remind you, just checking, I think it's my pen. This is a +1, +2, +3, +4 / -4, flips over, -3, -2, -1, no charge because they're noble gases. Yeah, so we find oxygen and sulfur in the -2, and we find nitrogen and phosphorus in the -3. So phosphate's always nice because phosphorus becomes a 3-, and the phosphate is also the only 3- complex ion that you actually need to actually know at A level. You don't need to know it at GCSE, but it's just nice to cover it. Yeah, and the bonding is the really tricky one. No one's given me that yet. Guys, level 8, 9, what is the bonding of ammonium sulfide, please? What's the bonding? And this is a trap. There is a reason for this being level 8 and 9. Yeah, it is a trap. It's tricky, this. So anyone want to have a shout out? It's a trap, which means it's going to be the opposite of what you think it's going to be. It's a trick. Oh, at Excel. I love it. Ethan thinks both of you are wrong. I know. The reason why is we know, just a quick reminder of bonding. Yeah. We know that there are 4 main types. Well done, Fatima. It's ionic. So the bonding is split into 4 types. We've got covalent. We've got giant covalent. I'll actually be good. Giant covalent. We've got ionic. And we've got metallic. Those are our bonding types. Yeah. And the way you always learn this is that metallic is easy because it's just a metal. Sodium, e.g. Yeah. Ionic is metal, non-metal. Yeah, this is what you learn at GCSE. Metal, non-metal. I'll put metal and, so the dash doesn't then make sense. They go metal, non-metal, and then all the covalents are non-metal, non-metal. Yeah, non-met and non-met. And this one breaks this rule. This is the only one that does it. It's not entirely true. There are others that do it, but this is the only one you must know at GCSE, which is the ammonium ion is a positive ion. Yeah, this is what, there you go. There's the ammonium ion, and the sulfide will be S2-. So it's going to be ionic. Anything that has ammonium in it is actually ionic and not covalent. You'd expect it to be covalent because there's no metal anywhere. Yeah, all non-metals. All non-metals. So you would expect it to be covalent, hence why it's a high level. Yeah, all non-metal. Expected covalent. But in reality, true ionic. Clever. Great game, that. Comes up fairly regularly as well at GCSE for at Excel. Right, let's now work out our percentage compositions. And by the way, this is much harder. In terms of percentage composition, hardest one we've had so far has been the copper bromide, but this one is now substantially harder. The reason being is there's a bracket. So let's work out nitrogen first. Let's divide it into 3. Gonna shrink my pen. Nitrogen, hydrogen, and sulfur. Remember, it will add up to 100 at the end of this. So nitrogen, we want the percentage composition is wanted over total. So here's the clever bit. Yeah, we've got percentage comp equals. The question is, how many nitrogens are in it? Nitrogen is number 14 on the table. Yeah, and how many nitrogens are in it? And the answer is 2. It's a trick, folks. Over the whole thing. 14 times 2 plus hydrogen, which is 1. But how many are there? And this is even harder. There's 8 times by 8 plus 1 sulfur at 32 times 1. I'm going to lose the mark for that answer in my exam, so I need to actually finalize that. 14 times 2 plus 1 times 8 plus 32, and I get a mass of 68 times by 100. So I'm going to have 28. Yeah, I'm just going to make that a little bit, give myself a bit more space here. Yeah, so that's 68. So that becomes 28 over 68 times 100, and I get a percentage of 28 over 68 times 100 gives me 41.2% 3 sig fig. There we go. So nitrogen is 41.2%. Tick it if you've got it. Right, hydrogen again is the tricky one because there's 8 of them. Yes, we want wanted. So we've got hydrogen, which is 1 on the periodic table. Its atomic mass, remember, not atomic number, times by 8 because it's 4 times by 2. Yeah, over the whole thing. Already done that at 68. Yeah, over 68 times 100. So 8 over 68 times 100 gives me 11.8% 3 sig fig. 11.8. This is by far the hardest one, folks. If you want additional questions after we've been through these, I can always give you them. Got loads and loads of them. Right, next one, sulfur, of course. There's only 1 sulfur in this now, folks. So that makes things a bit easier. So percentage comp equals wanted, which is sulfur at 32 over the whole thing at 68 times 100. 32 over 68 times 100, and I get 47.1%. Right, let's input my data. 40, isn't that interesting? The rounding actually gets me into trouble there. Yeah, because if you notice, it doesn't quite add up. Rounding errors, yeah. If I add all, it's going to end up with 100.1, isn't it? 41.2 plus 11.8 plus 47.1. 100.1. I get the fact that there's an issue there, folks, with the rounding, but try not to worry about it. Yeah, those answers would be correct. Those answers would be correct in your exam. Next. Okay, next one. Guys, so don't overthink it. We've reminded ourselves of bonding. So can someone on the classroom give me the bonding type, please? And can you, somebody else, this is hard. Ooh, give me the name. Oh, guys, that's hard. That's actually really hard. You guys actually, by the way, just to let you know that is technically outside of your remit. It's actually also technically outside of A-level, which is really interesting. Have a go, though. I will accept a basic answer. I shouldn't say basic because it could be a base, but it might be. Oh, I'm such a loser. Well done, Natanya. Absolutely superb. Great job. Yeah, it goes back to our normal rules. This is covalent. Well done, Natanya. Outstanding. Oh, look at that. Disulfur dinitride. Ethan, really, really impressed. Yeah, can you do me a favor? Can you switch it round? Yeah, well, guys, I'm really, I love that Fatima's now made it go to 8. Remember, 8 doesn't exist unless there's oxygen there, Fatima. Yeah, nice little addition there just to talk about. Yeah, just to remind you of naming, Fatima. Yeah, in naming, we know, I shouldn't have naming rules for chemistry is that we always know that the metal goes first, metal followed by the non-metal. So by the way, if, who was at the game? Ethan gave me disulfur dinitride. Ethan, they would allow that at GCSE and A-level, in fact. They would allow it because you don't know which one goes first, but you would actually name it the way that it's written. Yeah, and in fact, Bo Yang, you get 3 commendations, Bo Yang. It was a really superb effort. I'm actually going to give you 1 commendation because you need to change the ending. It's really close, though. You're the closest so far. Yeah. Dinitrogen, how's it going to finish? Come on, guys. No one's given me the correct name yet. So this is N2S2. So we're going to name it in order. Fatima, you've then lost the other bit that Bo Yang did really well. You need to put in the bit that he had. You're nearly there, though. This is dinitrogen disulfide. There you go. Isn't that interesting? Funny game. And now go figure. Dinitrogen disulfide. It is that is way dinitrogen disulfur. Bo Yang, flip it over. The first, remember when you do naming, so we did metal, non-metal, and then we realized that the metal, the first one, the metal name never changes. That never changes. So in this case, nitrogen never changes. But the non-metal changes. Yeah, the non-metal either becomes an ide. So an ide, if so, it was an S, so that becomes sulfide. Yeah, but it could also change, the name changes to an ide unless it's a non-metal and oxygen, which means it becomes an 8. Yeah, so dinitrogen disulfide, and the bonding is covalent. Natanya, well done, great job. Yeah, that's really tough, that, folks. Really tough. Okay, I feel like I want to put it there now. Dinitrogen disulfide. Isn't that cool? Love that. Great chemistry. Yeah, so we're going to work out this again. By the way, out of all of these, this one here by far was the hardest. Yeah, that's where I'd like everyone to be aiming to get to. Being able to read that and do, if you can do that one, you can do any percentage composition they throw at you at GCSE. So this one's relatively easy. There's only 2 people, nitrogen and sulfur. Right, so nitrogen, of course, on the periodic table has a mass of 14. There are 2 of them. Over nitrogen times 2 plus sulfur at 32 times 2. Right, I'm going to lose the mark at GCSE for doing that. 14 times 2 plus 32 times 2. And I get 92 times 100. So I get 28 over 92 times 100. And I get 30.4%. Winner. There we go. So 30.4%. Sulfur, of course, again, there's 2 of them. So we've got sulfur at 32 times 2 over the total, which we've already worked out, times 100. If I don't write this, I will lose a mark in my exam. Yeah, so 32 plus 32 over 92 times 100, and I get 69.6%. Let's just check that this adds up. If I go 30.4 plus 69.6, I get exactly 100%. Tick, 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 tick. So this worksheet, tick, 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 tick. So the worksheet is out of 10. It's out of 10 exactly, folks. Out of 10. Right. So what I'm going to quickly do is just drop onto I of course created a tracking sheet for you guys. So if I go to Google, there we go, and change over to that one and then do Drive. I think I started it. You guys can fill in your data. There's no rush here, folks. And then we're going to get on to moles. So we've got 15 minutes left. Starred. Pretty sure I starred it. Year 10 double homework data. There we go. Yay, percentage composition is there. There we go. So that one there is out of, it's working on it. This one here is out of 10. There we go. Love it. Out of 10. And you guys can input your data. That'd be lovely to be able to. Mr. Duncan, yes, Ethan, how can I help? We have another worksheet, right? Oh, did I set you another one? Did I set you another one that we haven't discussed? Oh, did I set you two? Wow. Which one have I missed? Which one have I missed? How did I go there? Don't know. The homework from last Tuesday. Oh, which one have I missed? What was the title of it? What was the title? What was the title of it? I don't know where I'm going to have that one there. Go back one. And then go to GCSE Calcs Homeworks. Equations practice. Oh, did I give you that? Was it this one by any chance? Was it that one? Check Google Classroom. Yeah, I can do. Was it this one? Oh, I did give you the equations homeworks. That's good. Yeah, brilliant. Right, I'll go through that one now, folks. That's awesome. And then we'll do moles next lesson. I'll change the title of the webinar. Insert printout. And this is, oh, don't know where I'm going to have put everything. I can download it. Print. Making my laptop work hard here. Mr. Duncan, I have a question. Go for it, Fatima. Go for it. That's what I'm here for, Fatima. Questions. Always. Let's do equations. Ooh. I've never done that. Equations. Oh, look at that. That's awesome. HW. How amazing is that? Oh, I didn't like that. Oh, that was really funny. In fact, it now has made a complete mess of it. It's brilliant. Let's see if I can bring up my keyboard. My laptop is, do you know what's amazing how, homework, let's just save that there to desktop and then I'll insert it. So what I'll do is I'll insert it down here if I can. Insert printout, equations homework, go. What makes a compound aqueous? When it's put into water. Aqueous, the word aqua comes from the Latin, I believe, for water. It's when something is in water. You realize that anything, in fact, anything can be a solid. Anything. Just going to move that. Zoom. See if I can get rid of that stupid thing there. Delete. Or I'm just going to move this. There we go. Just move that up there. There we go. Oh, that's better. Zoom. Winner. Right. I'll go through. Solution, right? Yes. The word aqueous also, another one that is when it is in solution. Yes, correct. When it has been dissolved in water. That's correct. Yes, well done, Ethan. So, you're wondering about this from the worksheet. Oh, I like it. So balance the symbol equations and then change to word. Wow. Guys, I've got 10 minutes. Okay, guys, is never going to get through all of this. But if I'd known, I probably wouldn't have done quite so much explanation on the other ones. Right, so balance the equation. 1 magnesium, divide it in half. 1 magnesium, 1 magnesium. 1 hydrogen, 2 hydrogens. Put a big 2 in front. Yeah, put a big 2. There you go. Next, 2. Now I've changed somebody. Start again. 1 magnesium, 1 magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. I'm good. We're finished. Yeah, there we go. Next. Then it says change to word. Ooh, it's going to be a lot of writing this to do in 10 minutes. We'll see how we get on. I'm so used to doing symbols. Magnesium plus hydrochloric acid. Now, just to tell you, by the way, this is Fatima's dad had a really good question here. That there means dissolved in water, aqueous. Yeah, and if you have an acid dissolved in water, then it's given the name acid, hydrochloric acid. If that was a gas, because HCl can also be a gas, that would be called hydrogen chloride. It's quite interesting, isn't it? And then I'm going to form magnesium chloride. You realize why symbol is better. You don't ever have to balance a word. Yeah, words don't need balancing. Plus hydrogen, nice and easy. Hydrogen gas, we're done. There we go. Next, balance the equation, 1 copper. Let's divide it in half. Yeah, 1 copper, 1 copper. 2 Cls, 1 Cls. Right, changed somebody, start again. Yeah, 1 copper, 1 copper. 2 Cls, 2 Cls. 1 sodium, 2 sodiums. Put it there. Right, changed somebody, start again. Yeah. Solid. Don't we have to write solid? Ooh, balance the symbol equations and change to word. Do you need state symbols? Nah, don't bother with the state symbols for word. Don't worry about that for this one. They would tell you if you need them. Students often ask me, no, you don't ever write down the word solid, Ethan, ever. You always write down, if you were going to give states, you'd always give it as a symbol, even in Word. Yeah, I know, isn't that funny? Great question. I don't think I've had anybody in the last few years come across that. Good question. Amazing. Sorry, getting distracted. 1 copper. I'm very aware. I've only got 9 minutes. 1 copper, 1 copper, 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums. Oxygens. 2 oxygens on this side. 2 oxygens on this side. 2 H's, 2 H's. I'm done. Whoop, whoop. Change to word. Oh, it's transition metal. Copper, 2 chloride. Yeah, if you wanted state symbol, you could put aqueous if you wanted. Plus sodium hydroxide, no Roman numeral needed because it's not a transition metal. Goes to copper 2. You need a Roman numeral again. Nightmare. Copper 2 hydroxide plus sodium chloride. There we go. Like it. Next, balance the equation. 1 phosphorus. Let's draw the line. Yeah, 1 phosphorus, 1 phosphorus, 2 chlorines, 3 chlorines. Common denominator. But the next question, look at task 2. It says like in Word. Oh. Do you need state symbols for task 2? Oh, yeah, it does. You're right, they'd never do that. That's madness. I totally see what you're saying, though. They'd never do that. But, Ethan, yeah, I totally get where you're coming from. If you've written it, great. If you've just put a state symbol, that's fine. They didn't actually need it for the first one anyway. Common denominator for this chlorine, of course, is in a pair. This is awkward because what we realize is, it's so irritating. My tablet just doesn't work as fast as I do. We've got 2 chlorines and 3. That's awkward. Yet common denominator is 6. So I'm going to make that one a 3 to make that 6 and add a 2 there to make that 6. I have changed somebody. Start again. 2 phosphorus, and I'm done. Yeah, change. This now becomes phosphorus. Yeah, state symbol S. Now he's done it now. Chlorine as a gas. They wouldn't care about the words there. And this is phosphorus trichloride. That's hard, that. Phosphorus trichloride. Students are now going to ask me, how did you know to include the tri? Because it was covalent. If it's covalent, you have to put di or tri in there. Or tetra. Yeah, just to let you know. It's hard, that. State symbol S. Next, I'm only going to get, guys, 7 minutes. Right, balance the equation. I feel like I'm making everything hard to see. Do this one in red. 1 phosphorus divided up. Yeah, 1 phosphorus, 1 phosphorus. 3 chlorines, 1 chlorine. Make it 3. Nice and easy. I've made a change. Start again. 3 phosphorus, 3 phosphorus, 3 phosphorus. 3 chlorines, 3 chlorines. I'm good. Right, next, hydrogens. 2, and 3. That's awkward. Common denominator. It's a 3 because the 3 multiplies whatever's in the bracket. Yeah, so that common denominator is 6. Multiply that by 2 and multiply this by 3. I've made a change. Start again. 1 phosphorus, 2 phosphorus. This is a nightmare. Gonna have to add that. I've made a change. Start again. 2 phosphorus, 2 phosphorus, 6 chlorines. Make a change. I'll try it again. Start again. Yep, 2 phosphorus, 2 phosphorus, 6 chlorines, 6 chlorines, 6 hydrogens, 6 hydrogens, 3 oxygens. Oh! Uh-oh. Oh, no. Through 6 oh, dear. Uh-oh. Didn't expect that to happen. Uh-oh. I got the hydrogens wrong. I'm sorry. I'm sorry. It's where I always panic. 2 phosphorus, 2 phosphorus, 6 chlorines, 6 chlorines. Yes, nice and slow. 6 hydrogens on this side. 12 hydrogens on that side. So I'm going to now do that to 6. I've made a change. Start again. Yeah. Wait, don't you need a 3 and a 3 in front of the water and HCl? No, it's getting bigger. Then we've got 2 phosphorus, 2 phosphorus, 6 chlorines, 6 chlorines, 12 hydrogens on this side. I've got 3 here times by 2, 6 hydrogens here, folks. Yeah, 6 hydrogens and 6 there, 12 hydrogens. And that now adds up. Oxygens, 6 and 6. I'm done. That was hard. Ooh, that was really tough. I've never seen one that hard at GCSE. Yeah, that's an A-level question, really. So this word is phosphorus. Phosphorus trichloride because it's covalent. Solid, thanks to Ethan. Plus water. Yes, you don't have to write dihydrogen oxide. But you just write water. Goes to, phosphorus hydroxide. Acid or alkali, folks? Is that an acid or an alkali? Aqueous, meaning dissolved in water, and hydrochloric acid, because it's dissolved in water. Hydrochloric acid. So the phosphorus... phosphorus trihydroxide, technically. There you go. You can divide your answer by 2. Oh my goodness, I can. 1, 3, 1, 3. You're absolutely right. It is an alkali. Well done, Fatima. You're absolutely right. They will also accept multiples of this. Well done for noticing, Kate. Outstanding. You can now divide this whole thing by 2 to give me 1, 3, 1, 3 mole ratio. Yeah, but by the way, they would also accept mine. They also accept any multiples, just so you know. Like it. 3 minutes to go. Not going to finish. Oh, guys, don't know how much you did in year 9, but this one is not tricarbon octahydride. It's not that. This is otherwise known as propane. Or this is into organics. This is an organic compound, which means it gains organic naming. And that one's propane. Propane, I haven't balanced it. I shouldn't have deleted it. 3 carbons, 1 carbon. I'm actually gonna change my color. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, oxygens, 6, 4, 10, 5, and I'm done. That God was so much easier than the last one, wasn't it? Ooh, ooh. Blimey. Words. Propane plus oxygen goes to carbon dioxide. Carbon dioxide and water. State symbols if you wish. All gases. There you go. If you're wondering why the water's coming out as a gas, it's because that's combustion. This is a combustion equation, which means it's going to be reaching temperatures in excess of 400. So the water's in gaseous form. Nice. Change to symbol. I've only got 1 minute left, folks. I'm never going to finish it. Never going to finish it. Blimey. Guys, I'm going to end the video here today, and I'll finish this off next lesson. I'm going to set you no homework because of that. Ain't that nice? Yeah. You know, do try it. There you go, guys. Guys, can I just say thank you so much for working so hard on those sheets. I'll put that one onto the tracking sheet. I'm going to add it. And I will. You've got no homework this lesson. I'll see you on Wednesday, and we'll finish that off, and then we're going to start on molds. Guys, have a great rest of your day. It's been great to see you. Yeah, have a good day. Bye. Oh, Natanya, so very welcome. It's always a pleasure to teach you guys. You guys are fab. Thanks.